Hello everyone, welcome to the YouTube channel of Tribonite. My name is Manoj. Today, let us learn about oral tribology. Oral processing involves tribological processes with a focus on soft tribology, which studies lubrication, friction, and wear of compliant surfaces in motion. This emerging field, known as soft tribology, is gaining momentum in research to understand how foods and beverages behave during oral consumption. Here in this figure, we can see the oral tribology as a system property. Properties of food, that is oral cavity, and food or oral cavity interacting system affecting the oral tribology. Lubrication consideration. Lubrication is typically depicted by a Strybeck curve, where friction coefficient is plotted against lubricant speed. Three main lubrication regimes exist: hydrodynamic, at a high speeds determined by fluid mechanics; boundary, at a low speed influenced by substrate properties; and surface films; and mixed, that is transition between the two. These transitions depend on fluid properties, surface characteristics, and film formation. In oral processing, all three regimes are encountered, with the dominant regime varying based on the food type and processing system. Here in this figure, we can see the schematic presentation of Strybeck curve for oral systems. Instruments used in the oral tribology. Various instruments are used to measure food lubrication properties during oral processing. The mini traction machine, that is MTM tribometer, is widely used, offering versatility in testing a wide range of entrainment speeds, that is from 1 to 3000 mm per second, and decoupling sliding and rolling friction for oral surfaces. This device evaluates lubrication behaviors for different fluids including food systems and beverages. Another tool, that is the optical tribometer cell, that is OTC, provides an in situ visualization of the contact zones and has been used to study the emulsion, coalescence, and particle distribution in gelatin gels using pig tongue sections. In this figure, we can see the schematic representation of commonly used tribometers. In this, we can see the PDMS is used as an example, but other materials can also be used. What is the role of saliva in oral tribology? During oral processing, interactions between food compounds and saliva can lead to three main outcomes: minimal interaction, where the salivary film's lubricating properties remain undisturbed; disruption of the salivary film causing an increase in the friction coefficient, potentially due to changes in the pH, ionic strength, or the protein aggregation influenced or induced by food compounds; and synergistic interactions, where certain food compounds can alter the properties of the salivary film, affecting the friction, mouthfeel, and the texture. These interactions play a crucial role in understanding how different foods are perceived and experienced during consumption. What are the conclusions? In summary, while soft tribology measurements provide insights to the oral behavior of the foods and their sensory attributes, correlating friction coefficients with specific texture characteristics remains a complex challenge. It's crucial to remember that tribology is a system property and not an inherent material property, emphasizing the importance of the instrument choice, surface selection, and model foods. Bridging the gap between the tribological measurements in vivo oral processes and sensory perception requires a better understanding of the entire system. These are the references for the information provided in this video. And in this video, we understood what is the oral tribology, what are the lubrication considerations, what are the instruments used, the role of saliva, and the conclusions. Thank you for watching this video. To get more details on the topics related to tribology, follow us on our social media pages on Instagram, Facebook, LinkedIn, and do not forget to subscribe to our YouTube channel Tribonite. Also visit our website on www.tribonite.org.